Hi everyone, so in this video it's going to be a quick run through of how you carry out a chi-squared goodness of fit test on your TI-Nspire calculator. So over here on the left we have an example. We're given some observed data and we're asked to conduct a chi-squared goodness of fit test at the 5% significance level for that data to see if it follows a normal distribution with a mean of 100 and a standard deviation of 10. Okay, so regardless of whether you're testing for a normal distribution or another type of distribution with a chi-squared goodness of fit, you need to calculate your expected frequencies. And in order to do that, you need to calculate your expected probabilities. So I'm going to set up in a spreadsheet 2 columns. I'm going to calculate my expected probabilities in order to calculate my expected frequencies. Now, my expected probabilities are just the probability of getting each of these scores in this table on the left if it did follow the normal distribution that's been defined. So I'm going to go to Menu, Statistics, Distributions, and it's the normal CDF function because it's cumulative. For that first entry, I'm going up to 80. So my lower bound I leave as some tiny number. My upper bound is 80, and the mean they've specified is 100, the standard deviation of 10, and I hit OK. Now it's up to you for the rest of the data. You can either go through that same process or you can fill, just drag it down. You can use the same function, automatically filled, and then you just need to edit the inputs here. So my lower bound and upper bound for my second row, are going to be 80 and 90. That's why it's giving me an error. It said 0. My next bounds are going to be 90 and 100. My next will be 100 and 110. That's my next row in my data table. And finally, my last row will just be my lower bound, 110, and my upper bound, some massive number. Great. So now I've got my expected probabilities. I need to calculate my expected frequencies. That's just going to be my expected probabilities multiplied by the total number of pieces of data. So if this score is different people's scores, it's just the total number of people. And I can get that by summing this frequency column. In this case, that's going to be 171. Now, particularly if you've got a lot of rows, in order to do this quickly, you can just type equals to, and you can specify the cell with the probability in. So that's going to be cell A1 multiplied by, and 171 we said was the total frequency. And I hit enter. And if I drag this down like I did before, you can see that the cell reference automatically updates. So now I've got my expected frequencies. In order to be able to do my test, I need to compare them with my observed frequencies. And those I already have. I just need to input them. So 11, 15, 71, 62, and 12. And now I can do my actual test. So Menu, Statistics, Statistical Tests, chi-squared goodness of fit. My observed list I've called observed. My expected list is my expected frequencies. My degrees of freedom. If you're a standard level student, you will just use that the degrees of freedom is the number of rows in the data table. So in this case, 5 minus 1, 4. If you're a higher level student, you need to watch out for whether any of the parameters of that normal distribution have been estimated, because that will affect your degrees of freedom. However, in this case, they haven't been, they're just given. So it's still the number of rows minus 1. So in this data table on the left, I have 5 rows, minus 1 gives me 4 degrees of freedom. And I hit OK. That gives me my p-value. I would recommend using standard form when you write this if it's such a small number, so 1.72 times 10 to the minus 5, and my chi-squared value. You would then need to compare them with your significance level, or p-value with your significance level, or your chi-squared value with your chi-squared critical value to see whether or not you're rejecting or accepting the null hypothesis. But that's the calculator work summarized.